The human endocrine system operates as a continuous hormone exit and re-entry system. Active hormones like estrogen carry powerful instructions for our cells. Once their job is finished, they must be aggressively deactivated and escorted out to prevent system overload. The liver serves as the initial exit preparation site. In this animated diagram, specialized enzymes attach a chemical sugar tag to the active hormone. This process, known as conjugation, neutralizes the molecule so it can be safely transported. This tagging process is only the first step. The final decision of whether the hormone actually leaves the body happens further down the line. The deactivated tagged hormones travel into the intestine, which acts as the body's final departure checkpoint. Waiting at this checkpoint is a highly specialized crew of gut bacteria called the Estrobolome. These microbes monitor the tagged hormones as they move toward the exit. Within this precise microscopic environment, the final fate of our hormones shifts entirely into the hands of these bacterial cells. The estrobolome monitors hormone levels to determine if the body is running low on active estrogen. When more estrogen is needed, bacteria deploy the enzyme beta-glucuronidase. It performs deconjugation, snipping the sugar tag off the hormone, returning the molecule to its active shape. The reactivated hormone then crosses the intestinal wall, re-entering the vascular highway. This continuous bacterial recycling loop allows the body to maintain stable hormone levels without having to manufacture new ones from scratch. Recycled estrogen travels through the bloodstream, navigating away from the gut and directly into skin tissue. These returning hormones bind to specialized estrogen receptors on skin cells. This interaction triggers the production of collagen and helps the cells retain moisture. We can see the result of this microscopic signaling. The constant arrival of these molecules maintains a strong, thick, and hydrated skin barrier. Healthy skin relies on gut bacteria sending the precise volume of recycled hormones through the bloodstream. This precision breaks down during dysbiosis, a state of imbalance where stress, diet, or excess testosterone allows opportunistic pathogens to overrun the estrobolome checkpoint. In this chaotic state, protective bacteria stop producing the molecules but seal the gut. The intestinal wall becomes physically leaky. The disorganized bacterial crew also overproduces the beta-glucuronidase enzyme, severing too many sugar tags and creating uncontrolled waves of reactivated hormones. As shown in this diagram, a dual threat now escapes the gut. Floods of excess hormones and jagged bacterial fragments slip through the leaky wall and surge into the bloodstream. Hormonal breakouts are the visible symptom of this structural failure at the gut checkpoint. When these signals reach the skin, the combination of excess hormones and inflammation overstimulates the sebaceous glands, forcing them to pump out thick, heavy sebum. This sebum clogs the pores. As this generated video shows, the gland becomes engorged, trapping inflammation inside and creating an environment where acne-causing bacteria thrive. Topical treatments often fail to resolve chronic acne because they address the surface damage rather than the continuous internal flood. Restoring the system requires dietary fiber. Fiber acts as the fuel that repopulates protective bacteria, which naturally slows the overproduction of recycling enzymes. Plant-based phytoestrogens also travel to the checkpoint. Once activated by microbes, they move to the skin and act as natural shock absorbers for erratic hormone receptors. As the gut wall seals, the volume of recycled hormones returns to a steady baseline, allowing the skin's oil glands to safely power down. Ultimately, clear skin and complete systemic balance depend on the health of the microscopic bacterial checkpoint inside the gut.